TYBSc syllabus USPH 05 PHP 05 wavelength by Edser's A pattern. The aim of the experiment is to determine the wavelength of a given monochromatic source. So you are given sodium source. You have to determine the wavelength of the sodium source by using the A pattern. Now here name of the scientist is given, Edser's A pattern. So here this A pattern is here. You can see this one. This A pattern is there. So you have to determine the wavelength of the source by studying the wavelength by Edser's A pattern. That is the aim of our experiment, to determine the wavelength of the source. Now what are the apparatus which you require? Sodium source, A pattern, wire gauge of 150 or 200, the telescope you require. So these are the requirements. Traveling microscope you require to measure the gauge spacing and the length of the crossbar. So these are the required apparatus for the performing this experiment. Now here you can see in the diagram, this is the source of the light. So that source, A pattern, Edser's A pattern, you will keep very close to the source. So here this one, we are keeping it close to the source. Then here wire gauge is mounted on this stand. You can see this wire gauge. Here it is represented this way. And this telescope, you will keep it at a long distance from the A pattern. This telescope should be at a 2-meter distance away from the A pattern. So this will be the experimental setup arrangement which is there required for performing this experiment. Now the basic idea or the physics behind this experiment is that this wire gauge, the number of lines are there very close to each other, and it will act as a diffraction grid, and it will produce the image of the A. That image of the A, multiple images of the A, original image of A followed by the both the sides, multiple images of the A will be there. So how it will look? This way it will look. A will be there, and on both the sides of it multiple images of A will be there, and the crossbar of the A of multiple images and the original A, if they are in a straight way, so crossbar should be linear. So you can see this multiple image, this is a such way there will be a number of images. So crossbar should be there in a straight way. So the crossbar of all the A's should be in a straight. Then at that time you will have to take the readings. What readings we have to take, that I will explain you step by step. Alright. Now this, once you do this, the first step of the experiment is to determine the length of the crossbar. Now here this A pattern, the A pattern, there is a cross. You can see this. Now when you draw the A, there is a crossbar of A, this one. Now you mount this A pattern in front of the traveling microscope. Vertical crossbar you keep on the left side of that crossbar. You keep it on the right side. So here to determine the length of the crossbar, microscope reading left side, right side, take the difference, that will give the length of the crossbar. 9. Take one more observation, write the mean, that is the determination of the length of the crossbar by using the traveling microscope. Now here this A you will have to mount on the stand, so that I will show you as a next part of the experiment. Then to determine the gauge spacing. Gauge spacing in this wire gauge which is there, you will mount it on the stand. This stand you will keep in front of the telescope. Then you take the reading for any one line, vertical line, one number. The gauge number will be there, 150, 200 is marked on that. You can see these are the gauge numbers here written there. Alright, here it is 150. Now first line, any number line you call as a 1. Take the microscope reading on that, and then you take the reading for fifth line. Count by slow motion screw. You go to the fifth line, take the microscope reading, then 9th and 13th. Then difference between 1 and 5, that will be the 4D. 5 and 9, that will be 4D. 9 and 13 will be 4D. Take the mean of 4D, divide by 4, you will get the gauge element. Gauge element determination you have to do. That will give you the D. D you got the length of the crossbar. Then actual experimental part is to measure the D. D means distance between A pattern and the wire gauge. When all the image of the A and multiple images are A, the crossbars are linear. So crossbar should be in a straight way. So you can see here it is shown in the diagram this way. The crossbar should look like this way. Then that time you have to measure the distance between the A pattern and the element. This will be your D. For 150 you have to measure that. Here you have to write the D. For 200 also you have to work. Replace this by 200. Measure the D. Then what is the formula for wavelength of the source? Lambda is equals to LD upon 2D. D you got, L length of the crossbar, D the gauze element. Substitute it in the formula. You will be in a position to get the wavelength of the given monochromatic line. Alright. So this is the procedure of the experiment which you are having. The determination of the wavelength of source by using the Edser's A pattern. Now here, how will determine the gauze element? This wire gauze. Take it here. Focus the telescope. Put it in front of the telescope. Switch on the light, table lamp. Then focus it on that. Take first line, second, third, fourth. Observe those lines. Take the reading for the first, take the reading for fifth, then 9, then 13. And the distance between 1 and 5, that will be 4D divided by 4, you will get the gauze element. So this way the arrangement you will have to make. Table lamp you will have to use for taking the readings. Alright? This. Properly you focus the traveling microscope on that to get the gauze element D. Right? Then you will have to measure the length of the crossbar. So here you replace it by from here, and you can measure the length of the crossbar of the A pattern. So focus it on that. Alright. So the crossbar will be visible. Now you can measure the length of the crossbar by focusing on it. Crossbar A will be there. So you take the vertical crosswire on the left side, you take the right side, difference will be giving you the length of the crossbar. So height of this you should adjust properly so that it will be exactly in front of it, and focus it properly so that you will get the image. Light should be there so that you will be able to see image of the A. So from here, yellow light. Stop it. Stop camera. The gauze element. Focus the traveling microscope on the A pattern. See the image of the A pattern through the traveling microscope. Take the vertical crosswire on the left hand side. Take the reading of the traveling microscope. Then shift it to the, by slow motion screw you will shift it to the right hand side. So here it should be vertical here, then it should be vertical here. Vertical crosswire should be here, tangential to this point, and vertical here at the right hand side. Then difference between the two readings will give you the length of the crossbar. So like this way the length of the crossbar can be determined. Here you will determine even the gauze element also you can find out by mounting the gauze here.